Hey guys, so here is day 2. We're going to be talking about word problems and the number e. So we're going to talk about decay and growth rates, and then identify real world problems dealing with principal and interest and compound, as well as using our PERT formula when compounding interest continually. Okay, so let's go ahead and talk about exponential growth and decay. So we know that when our b value is greater than 1, that is what we call a growth function, right? Now, when we are dealing with word problems, basically our growth model is going to be as so. It's going to be y equals a times 1 plus r to the t. Now let's talk about what each of these variables represent, okay? A is what we call the initial amount. Okay, y is basically your final amount. R is going to be our rate, and we will need to put that as a decimal. And then t is going to represent time. Okay, now let's talk about when we have a decay function. So we know we have a decay function when our b value is between 0 and 1. So basically a decay model is going to be as so. So it's going to be really very similar to what we just did with our growth model. The only thing is, instead of having a plus r, we're going to have a minus r. So we're going to have y equals a times 1 minus r to the t power. Okay. Yes. So once again, y is going to be your final amount. A is going to be your initial amount. R is going to be the rate, and we want to make sure that's as a decimal, and T is going to be our time. Okay? So make sure you pause this so you can get all of that stuff down that you need to. Okay, so now let's apply these growth and decay models to the following problems. Okay, example 1, it says in 1996 there were 2,573 computer viruses and other computer security incidents. During the next 7 years, the number of incidents increased by about 92% each year. So here it says write an exponential growth model giving the number n of incidents t years about 1996. Okay, so the next thing is they told us what type of model, but let's say they didn't tell us to write an exponential growth model. How could we tell that we would have to do a growth model anyways? Well, there is a key word. It says the incidence increased. Okay, so anytime you see the word like increase or growing, that always means you're going to use a growth model. Okay, so our growth model, remember, is y equals, and we're going to have our a times 1 plus r to the t. Okay, so we will still have y. A is our initial amount. So basically, how many incidents or computer viruses did we have initially? That is going to be 2,573. Okay. Now we have to think about our rate and our time. Now, when we are writing basically an exponential growth model, our t is going to stay as t. So really we have y and t, or you can think t of as x as well. So we're going to have 1 plus. Now, our rate has to be as a decimal. The rate we're going to use is 92%, but we have to change that into a decimal. So remember, to change into a decimal, we move it to the left twice. So it's going to be 0.92. So we're going to have 0.92, and that's going to be to the t power there, okay? Now, we do want to simplify this, so we did simplify it here. This will be y equals 2,573 times 1.92 to the t power. So that's going to be our growth model. Now, our next thing it says about how many incidents were there in 2003, okay? So what we will need to do is we're going to plug in a value in for t because we're trying to find the final amount of incidence. Now we're not going to do this part, so I'm going to go ahead and scratch this out. Okay. So to figure that out, we do start at 1996, right? So to find our t value, we do have to do 2003 minus 1996 to find that. And when we do that, we do get 7. So t is going to be 7 here. So using my growth model, I'm going to have y equals 2,573 times 1.92 to the 7th power. Now, all we need to do here is just plug this into our calculator, okay? So this is something you do have to use a calculator for. So I have 2,573 parentheses 1.92, and then you want to use the caret key, and then we'll do number 7, and boom. Okay, so let's go ahead. We're probably going to round to the nearest whole number because that would make sense, because there's really not going to be a 0.71 virus, okay? So let's go ahead, we'll round up to 85 here. So we have about 247,484 incidents with viruses or computer viruses. Okay, let's go ahead and do the next one. So here it says a snowmobile costs $4,200. The value of the snowmobile decreases by 10% each year. We need to write an exponential decay model giving the snowmobile's value y after t years. I'm going to get rid of this. Okay, so we're writing the model. Now, it does tell us to write an decay model, exponential decay model. But how could we tell without using that? Well, know that says the value of the snowmobile decreases, okay? So if you ever see anything decaying or decreases, meaning you see those words, that means we need to use a decay model. Okay, so remember our decay model is y equals a times 1 minus r to the t. So from here, we have y equals, so initially the snowmobile cost $4,200, right? So then I have 1 minus, now I need to see by the percentage it decreases. It's 10%. Now remember, we need to change that 10% into a decimal. So that's going to be really just 0.1. Okay? So we have 1 minus 0.1 to the t power here. Okay? Because t, we don't really know how many years we're using that as our variable. Now I'm going to go ahead and simplify this so I get y equals 4,200 times, now I do 1 minus 0.1, so that is going to be 0.9 to the t power. So this will be our final answer here. Okay. Now let's go ahead and talk about the next one. Then it says estimate the value after 3 years. So my 3 years, that's going to be my t value. So I'm going to use my decay model, so the 4,200 times 0.9, and put the 3 there. So now, once again, I just use my calculator to find the answer here. So I have 4,200 and then 0.9 to the 3rd. And it's now about 3,061 and 80 cents. So we do have decimals because, you know, this is money. It's fine to have decimals. Okay? And don't forget your $sign to represent, hey, this is money. Okay? Make sure that is correct. There we go. Okay, make sure you watch the next part of our video. We're going to talk about interest.